Okay, some more stuff on laws of exponents. In the last chapter, we used the first three laws, and there's a video on that if you need to review that. But law 4 and 5 I want to review again. And 4 is interesting because there's two parts on it based on the exponent of the top and bottom variables here. When m is greater than n, in other words, when the top has a bigger exponent than the bottom, notice the bases are the same, so I'm doing 2 to the 8th over 2 to the 5th. When the top is larger, you write the answer as the base 2, and you take and you subtract 8 minus 5. And you get 2 to the 3rd, which is 8. So that's the answer for that one. When the exponent on the bottom is the one that's bigger, we're using the second part of that rule. So the answer becomes a to the 1 over a to the n minus m. So think of that as your m, and that is your n. So when the bottom is bigger, I end up keeping the answer as a fraction. The 3 is on the bottom, and I go 5 minus 2. So here I get 1 over 3 to the 3rd, which is 1 over 27. So be careful when you have fractions. First thing, make sure the two bases are the same that you're working with for exponents. And then there's two samples that should help you out a little bit. Other than that, here's a problem that uses both of those rules. Suppose you have this, 9x to the 3rd y squared over 3x squared y to the 3rd. All right, first of all, let's do the coefficients. 9 over 3, does that reduce? Yeah, 3 goes into 9 3 times, 3 left on top. I could put a 1 on the bottom if I want. I don't need it. All right, let's take the x's. The top has a bigger exponent than the bottom, so that's going to be x to the 3 minus 2 left on top. The y's, the bigger exponent's on the bottom, so it's going to be y to the 3 minus 2 on bottom. Final answer for this is 3x to the 1 over y to the 1. And there's the answer. And that problem used both rules here. So be careful with those rules. Okay, I have another example here that's kind of scary looking. I need to multiply all of this together and simplify. Notice there's y's on the bottom here and the top here. You think I can reduce that? Not yet. This whole quantity is to the power 3, so I have to deal with that first. So I'm going to rewrite the problem. 4x over 3y to the 7th, and I'm going to take care of figuring this part out first. So it's y to the 4th to the 3rd. So power to a power, multiply those. So 4 times 3 is 12, so that's y to the 12th. On the bottom, I have to cube this, so 2 to the 3rd, 8, x squared to the 3rd, x to the 6th. Multiply the exponents, right? Now, what can I do? I hope you notice you can do some reducing. I could do 4 into 8, there's 2. I could do y to the 7th, take 7 y's from here. What do I get? Y to the 5th, right? What else? Oh, there's 1x here and 6 here. Can I reduce one of those? So take one of those and make that x to the 5th. So what does the final answer look like? Got to be careful here. Y to the 5th on top, and on the bottom 3 times 2 times x to the 5th. 6x to the 5th. Hey, can I reduce those 5's? No way. Hope you didn't get tricked on that. All right. There's a nice example.